Hello and welcome everyone. This is Mohammad Izamam from Saimedha Ecet Coaching Center Koti, Hyderabad. Saimedha Koti, Hyderabad is providing a golden opportunity to all the Ecet 2024 and as well as Ecet 2025 students. ఎవరైతే ఫైనల్ ఇయర్ లో ఉన్నారో, ఎవరైతే థర్డ్ సెమిస్టర్ లో ఇప్పుడు చదువుతున్నారో, Saimedha Koti, Hyderabad is providing the online coaching and as well as offline coaching for it. Ranks గురించి చెప్పాలంటే Saimedha Koti, Hyderabad లో every single time, every single year we have proven that maximum ranks in all the branches EC, EEE, mechanical, civil and computer science లో top 5 branches లో state first rank తో పాటు maximum ranks in top 10 and top 50 లో కూడా maximum ranks are there. In this video lecture series in the YouTube, we are going to be updating every single day for all the branches subject wise and as well as topic wise. Previous Ecet examination questions will be explained by expert faculties. My dear students, గుర్తుపెట్టుకోండి, ఓన్లీ ప్రీవియస్ ఇయర్ కాంపిటేటివ్ ఎగ్జామినేషన్ క్వశ్చన్స్ కొరకే సపరేట్ కోర్స్ ఉంటుంది, పే చేయాల్సి ఉంటుంది బయట మార్కెట్లో. కానీ Saimedha Koti, Hyderabad లో ఫ్రీ ఆఫ్ కాస్ట్ we are providing that series guys in this very YouTube channel. So those who have not subscribed the channel, subscribe now and press the bell icon to be notified for the further more updates. Every day subject wise, topic wise, previous Ecet examination questions with which you can understand the level of teaching, the expertise which is there in the Saimedha Koti, Hyderabad. So my dear students, what are you waiting for? Start watching all the video series in this YouTube channel. At the end of the video, I'll be coming back to give you a surprise for all the Ecet 2024 and Ecet 2025 aspirants. So share this video as much as possible for all the final year students and third semester students. Now let's start the video.
Yes, this is TS Ecet 2015 question. A rectangular metal waveguide filled with a dielectric of, this is of, dielectric of relative permittivity epsilon r equal to 4. It has the inside dimensions 3 by 1.2 centimeter. Then the cutoff frequency for the dominant mode is. The cutoff frequency for the dominant mode is. See here is asking cutoff frequency. So what is cutoff frequency formula in free space means Fc equal to C by 2 into under root of m by a whole square plus n by b, m by a whole square plus n by b whole square. And remember, this cutoff frequency always represents in gigahertz. So what is cutoff frequency formula here? Fc equal to C by 2 into under root of m by a whole square plus n by b whole square gigahertz. Now is asking question that is not free space. The question is related to a dielectric medium where epsilon r equal to 4. So epsilon r value is given as 4 and dimensions of the waveguide is also given a by b. A by b is given as 3 by 1.2 centimeter. 3 by 1.2 centimeter. Epsilon r equal to 4 is given. A by b is given as 3 by 1.2 centimeter. Then is asking cutoff frequency. So A value is given 3 centimeter, B value is given as 1.2 centimeter, means what? Here A greater than B. If A greater than B, then the dominant mode is what? TE10. TE10. In TE10, what is 1? M value, and what is 0? N value. So M value is 1, M value is 1 and N value is 0. Remember. Now I am considering all these values, M value 1, N value 0, A equal to 3 centimeter and B equal to 1.2 centimeter. And one more condition is given, epsilon r is given. So I am considering actual formula Fc equal to 1 by 2 root mu epsilon, 1 by 2 root mu epsilon into under root of m by a whole square plus n by b whole square. M by a whole square plus n by b whole square. This is cutoff frequency formula of a waveguide in a medium. If it is a free space, mu becomes mu naught, epsilon becomes epsilon naught, then 1 by under root of mu naught epsilon naught is what? C. So this is first formula is related to free space, Second formula is related to in a medium, because now medium is given, relative permittivity value is given. So, by using these two equations, now I am writing a new formula. Cutoff frequency in a medium Fc equal to C by 2 root epsilon r. C by 2 root epsilon r into, here m value 1, n value 0. So, root square cancel, m value 1 by a. So, remember the formula, C by 2a root epsilon r. This is the formula. Fc equal to C by 2a root epsilon r. Now, here a value, b value in centimeter, that is why I am writing speed of light is also centimeter per second. Generally, the speed of light in free space 3 into 10 power 8 meter per second, but generally in waveguides a and b are in centimeters, that is why we are writing the speed of light is also in centimeter per second. Then what is the speed of light in centimeter per second? That is 3 into 10 power 10. So, I am writing here Fc equal to, see here, 3 into 10 power 10, that is speed of light in centimeter per second, divided by 2, then no need to convert from centimeter to meter. Directly I am writing a value 3 centimeter and epsilon r value is given as 4. Epsilon r value is given as 4. Then 3 will be cancelled, that equals to 10 power 10 divided by root 4 value 2, 2 2 ja 4. So, 10 power 10 by 4 I am writing as 2.5 gigahertz. I am writing 2.5 gigahertz. How means? See here, 10 power 10 I am writing 100 by 4 into 10 power 8. 10 power 10 I am writing 10 power 8 into 10 square. The 10 square means what? 100. So, 4 1 ja 4, 4 2 ja 8, 4 5 ja 20. 25 into 10 power 8 is the answer. But generally cutoff frequency always represents in gigahertz. Therefore, when I am converting this value into gigahertz, 2.5 gigahertz. 2.5 gigahertz is the answer. Option 2 is correct. Option 2 is the correct answer. Next question. The velocity of electromagnetic wave in a good conductor. So, is asking velocity of a good electromagnetic wave. So, Vp equal to omega by beta. What is beta here? Phase constant. What is omega here? Angular frequency. So, propagation constant gamma equal to alpha plus j beta. So, according to conductor, what is the condition for good conductor? Sigma equal to infinity and epsilon equal to epsilon naught into epsilon r and mu equals to mu naught into mu r. This is the condition. By using this condition, if you consider, then the velocity of electromagnetic wave in a good conductor is very low, because here beta value is what? Phase constant value is more, because in wave, when wave is propagating through conductor, what is the value of sigma? It is infinity, hence velocity in a good conductor is very low. That is why we are using, all communication applications are used in high frequency region, because in high frequency region the medium acts as a good dielectric. So, option 3 is correct here. Next question, question number 15, TS 2015 question. A plane electromagnetic wave travels in a dielectric medium of relative permittivity 9 relative to free space. Then the velocity of propagation in the dielectric. Yes. So, velocity of propagation, velocity of electromagnetic wave in the waveguide, what is the formula? Vp equal to omega by beta. From that I am writing 1 by under root of mu epsilon. Mu epsilon. Mu is permeability, epsilon is permittivity. Now, in a dielectric medium is asking, So I am writing the same formula C by under root of epsilon r, because I am considering, according to question, we are considering mu r equal to 1. Then what is the relative permittivity value is given here? Relative permittivity epsilon r value is given as 9. Relative permittivity epsilon r value is given as 9. Then velocity of propagation Vp equals to C by under root of epsilon r, that is 9, C by 3. What is the value? C by 3. So when electromagnetic wave travels in a dielectric medium of relative permittivity 9, then the velocity of propagation reduced by a factor of 3. Vp is equals to, here in this case, C by 3. Therefore, velocity of propagation reduced by a factor of 3. Option 4 is correct. Now we are discussing next question, question number 16, TS Ecet 2016. Dominant mode in a rectangular waveguide. See here, dominant mode, just explain what is the definition of dominant mode. It is the mode of the waveguide which gives minimum cutoff frequency and maximum cutoff wavelength. Default, what is the correct answer? TE10 is correct answer, default. But sometimes you will give dominant mode in a rectangular waveguide where the dimensions of the waveguide is A by B, and if A greater than B, then only this answer is correct. If A less than B, then what is the answer? TE01. Here not any mention, no mentions are there here, the size of the waveguide. So default you consider A greater than B, then what is the answer? TE10 is the correct answer. Option 3 is answer. Next question, question number 17. This is 2016 Ecet question. Phase velocity of a transverse electric mode in a rectangular waveguide. See here, phase velocity formula is what? C by under root of 1 minus Fc by F whole square. This is phase velocity formula in free space. So here phase velocity is asking in TEMN mode is greater than velocity of light, is equal to velocity of light, is less than group velocity, is greater than velocity of TEMN mode in rectangular waveguide. The correct answer is phase velocity is always greater than velocity of light. Similarly, you remember one more term, group velocity. Group velocity is always less than velocity of light. You remember this term also. So phase velocity is always greater than velocity of light. Group velocity is always less than velocity of light. Sometimes they are asking order also, Vp greater than Vc, velocity of light, Vc greater than Vg. Remember, Vp greater than Vc greater than Vg, and you remember one more relation also, Vp into Vg is equals to Vc square. These all are previous set questions. Here they asked only one question, phase velocity of a transverse mode in a rectangular waveguide is always greater than velocity of light in free space, Vp greater than C. That is option 1 is correct answer. Next question, question number 18. The cutoff wavelength for TE10 mode for a standard rectangular waveguide. So here just now explain formula Fc equal to C by 2 into under root of m by a whole square plus n by b whole square. This is cutoff frequency formula. Now from the definition of wavelength lambda c, generally lambda equal to c by f. So I am writing lambda c equal to c by fc. Then cutoff wavelength formula from cutoff frequency simply 2 by under root of m by a whole square plus n by b whole square. Remember, 2 by under root of m by a whole square plus n by b old square. This is the formula. And he mentioned the size of the waveguide is A by B, because see all options are in terms of A. So default you understand A greater than B. If A greater than B, what is the dominant mode? TE10. So if A greater than B, the dominant mode is what? TE10. In TE10 mode, what is the M value? 1. What is the N value? 0. So M value 1, N value 0. From this I am writing lambda C is equals to 2A. I am writing lambda C equal to 2A. Then what is A value? So that is only asked, they ask question. So the cutoff wavelength for TE10 mode, a standard rectangular waveguide is what? 2A. Option 1 is the correct answer. Option 1 is correct answer. So next question, question number 19. The dominant mode in most waveguides is, just now explain. So your correct answer is what? TE10 is a dominant mode. But you remember one condition every time explaining, if A greater than B. And the dominant mode in TM means this is in TM mode. In TM mode, what is the dominant mode? TM11. If A less than B, what is the dominant mode? Means remember TE01. Sometimes they asked circular waveguides also. In circular waveguides, the dominant mode is TE11 also. But is asked simple question. TE10 is the most waveguides, most of the waveguides dominant mode. Next question, question number 20. A signal propagation in a waveguide has a full wave of electric field intensity change between the two further walls and no component of the electric field in the direction of propagation. So from the definition, see here, I am considering here two full wave components, but no component in the direction of propagation, means the dominant mode is TE20. What is the dominant mode is here? TE20, M value 2, N value 0. M value 2, N value 0, because number of half wave components in electric field along x direction is 2, he mentioned, but no electric field component in y direction is mentioned, hence N value is 0. So correct answer is here TE20 is the answer. Next question we are discussing, question number 21, AP Ecet 2018 question. The dominant mode in circular waveguides. So rectangular waveguide, based on the shape of the waveguide, waveguides are classified into two types. One is rectangular waveguide and second one is circular waveguides. Circular waveguides. So here is asking, the question is related to circular waveguide. So just now I told, based on shape of the waveguide, this is circular waveguide, and based on shape, this is rectangular waveguide. See here. So what is the dimension here? A and B, and very important, in circular waveguide the dimension is in terms of R. So according to that characteristics, if you compare, then in rectangular waveguides the dominant modes, in rectangular waveguides the dominant modes are, remember, TE10 and TE01 according to the dimensions of A and B. But if you compare in circular waveguide, the dominant mode is TE11 only. Hence, which option is correct? Option 1 is the correct answer. TE11 is the dominant mode in circular waveguide. Next question, question number 22, AP Ecet 2018, the K-band frequency range of radar. Actually this is radar also question, but generally we are using in micro frequency spectrum. So 122, 224, 4 to 8, 8 to 12, 12 to 18, 18 to 27 and 27 to 40, all frequencies are gigahertz. So L band, S band, C band, X band, KU band, K band. So what is the answer here? 18 gigahertz to 27 gigahertz is the correct answer. Option 3 is answer. Next question, question number 23, TSE said 2018 question, the modes of propagation supported by a rectangular waveguide. So very important, TE and TM modes are only exist in waveguides. TEM mode does not exist. TEM mode does not exist in waveguide. Only TE mode, TM modes are exist. What is the meaning of TEM? Suppose wave is propagating along plus Z direction. In transverse electromagnetic mode, TEM mode, Ez is equals to 0 and Hz equals to 0. Ez equal to 0 and Hz equal to 0. There is a condition, wave propagating through along plus Z direction only. Now, when the two components electric fields are vanishes along the direction of propagation, then such type of modes are not existing in waveguide. So, then how a wave is propagating through waveguide means at least one of the field component, either in electric field or in magnetic field, is not equal to 0 along the direction of propagation. So here we consider the wave is propagating along plus Z direction. So to propagate an electromagnetic wave through waveguide, at least either Ez is not equal to 0 or Hz is not equal to 0. TE and TM modes are only exist in a rectangular waveguide, hence option 2 is the correct answer. Next question, question number 24. The dominant mode TE mode in a rectangular waveguide. So in rectangular waveguide, what is the dominant mode? TE10. See, this number of time they asked question. So what is the correct answer? Option 3 is the correct answer. Next question, again their question, same option repeated. The modes of propagation supported by a rectangular waveguide is again TE and TM modes are only existing. Remember, TM mode does not exist. Next question, question number 26. In TE10 mode, wave propagation, if the broader dimension of the waveguide is 4 centimeter, what is the broader dimension? A value is given as 4 centimeter. Then what is the cutoff wavelength? So here in TE10 we are comparing with the standard TEMN, then M value how much? 1, and what is the N value? 0. M value 1, N value 0, cutoff wavelength formula lambda C equal to 2A. Cutoff wavelength formula is what? 2A. If A less than B, 2B. So here A is greater than, only broader dimension mentioned. So 2 into A, what is the A value? 4 centimeter, that equal to 8 centimeter is the answer. Option 1 is correct answer. So 8 centimeter is cutoff wavelength of the mode.
So my dear students, for Ecet 2024 and Ecet 2025, Saimedha Koti Hyderabad is providing maximum concessions in this very week. Offline students gavachu, online students gavachu, online plus offline students gavachu, morning batches, evening batches, day batches, full day batches, online courses with materials gurinchi Saimedha Koti Hyderabad in this very week, guys, in this very week only we are providing the maximum concessions. A concessions evaithe unnayo, concessions ఏ విధంగా ఉంటది, batches ఏ విధంగా ఉంటాయి, with materials, without material, online coaching, total మీకు ఏ డౌట్ ఉన్నా సరే ఆ కన్సెషన్స్ మాక్సిమం ఏమున్నాయి అంటే మనకు మొబైల్ నంబర్స్ ఇక్కడ స్క్రోలింగ్ లో ఆల్రెడీ ఇవ్వడం జరిగింది. సో స్క్రోలింగ్ అవుతున్న మొబైల్ నంబర్స్ కి కాంటాక్ట్ చేయండి అండ్ జాయిన్ ఇన్ ద Saimedha Koti Hyderabad as soon as possible. Don't miss this opportunity of getting the maximum concessions, guys. Thank you very much. In this video series, every single day we are going to be updating subject wise, topic wise, previous Ecet examination questions. I wish you all the best. This is Mohammad Inzamam signing off.